guys, welcome to my channel. If you are watching my channel first time, please subscribe my channel. So guys, in this video, I'm bringing you the how to use trigonometric functions using Python's math library, and also how to use all kind of inverse trigonometric functions and hyperbolic functions, and about angle conversion, and also we will discuss about some of the mathematical constants also. So first step is we need to import the math library because all these functions are available in Python's math library. So we have imported math with this. Now first we'll discuss about angle conversion. Why? Because all the trigonometric functions that we have in Python's math library, so they use radians, angle in radians. So input should be in radians. So generally we have habituated to use degrees in general. So whenever we want to give the input, so we need to convert the degrees into radians. So for that that angle conversion is possible. So how to do that, let us see first. So let me take x equal to, for example, 90 degrees. This is in degrees. Now I will say y equal to math dot radians. There is a function called radians. So x I want to convert, then I want to print here y. Okay, so if I execute this code, then what I'm getting is 1.570. So this is what the equivalent value of the radians for 90 degrees. Now something like 45. So if I say 45, then that will be so 0.7853. Okay, so similarly we do have a function in reverse way also, we can do it. For example, let me take x1 equal to, so 0.7853 up to 4 digits we will take it. Then I will say y2 or y1 equal to math, so math dot degrees. Okay, so we have a degrees of x1 we want to convert, and finally I want to print y1. So y1 will be printed. Okay, so now if I see this, so what we need to get is 45. Yes, because we have taken only up to 4 digits, that's the reason it is giving 44.99. so which is almost approximately equal to 45. If you give entire this thing now, so then ultimately we will get into 45. So means we can use radians function that converts angle from degrees to radians, and opposite, if you want to convert into degrees now, you can give input radians, then automatically degrees function will convert for you. Okay, now let us see how to use math functions, so sorry, trigonometric functions. So for example, let me take x1. So what x is in radians already, so anyway I'll take x2 equal to something like I'll say math dot. Okay, so I can use x2 equal to something like 0.7853, the same value I'll use. So this is in radians now, so I'll say y2. Now y2 equal to math dot sin, sine, so sine of x2. So if I give this, then I'll print, so print y2. If I ask sine for this corresponding angle, then it is 0.707. Okay, so it is 45. So all of us know that sine 45 is equal to 1 by root 2. 1 by root 2 is nothing but that is what 0.707. This is correct. Now for example, if I say 1.57 here, if I use 1.5 1 point sorry 1.578, something like this. Okay, now what could be the thing? So this is what 0.99, because sine 90 approximately is equal to 90. So sine 90 is 1, that we know. Now if I want to use a function, so here I'll replace my sine with cos, because cos 0, cos 90 is 0 approximately. Okay, okay, so that is what cos 0 is 1, and it is giving almost this value. All right, so if I run it once again, then it is taking some kind of thing. So it is what 0.007 it is. So this is how generally it goes on. So it gives so similarly I can find, so it is better if you take a middle angle which is in the middle. So I'll take 0.7. Then I will use tan function here, tangent function. So tan. So now if I say substitute here, now if I run here, then tan 45 is equal to sine 45 by cos 45, which is 1. So it is approximately equal to 0.99, because here why we are getting not exactly getting 1 means because I took only 4 digits after decimal point. If I took accurate value, then that will be very interesting. Okay, so that will give you very good idea. So then inverse functions also possible. So for example, let us discuss about the inverse function. I want to add new code box here. So yes, so it is added. So here yeah, anyway, so let me take x3. Okay, I don't want to add here, I want to add after this. So I will select here, then I will say plus. Yeah, so x3 equal to, so for example I want to get 1. Okay, 1.0 exactly. So I'll say y3 equal to math dot. Now a sign is nothing but arc sign, which is nothing but sine inverse of x3. So now I want to find out what is the angle. The output will be angle. So now I'll print y3. So what is y3 here? So for example, let us execute this. Yeah, it is 1.57 radians. It is in radians. Now if I convert into degrees now, then I can say, so print math dot degrees of y3. I want to get y3 value in degrees. So now what I'll do is I'll re-execute it. Now it is giving exactly 90 degrees. Okay, similarly I want to calculate cos inverse. So I'll use a cos stands for cos inverse. So now if I execute this program, then so cos inverse of 1, so basically 0, because cos 0 is 1. So cos inverse of 1 is 0. It is giving the right answer. Similarly tan inverse, everything you can do. Similarly we can use hyperbolic functions also. So hyperbolic functions are nothing but cos h sin h, like that we have to use it. So it supports, this math library will support like all the regular trigonometric functions and also hyperbolic functions and also inverse trigonometric functions. So how to use all these things we have seen. So if you want to use hyperbolic function, you have to use cos h sin h. That stands for cos h, cos hyperbolic. Similarly sin h hyperbolic. And even you can use inverse hyperbolic functions also, like for example a cos h. So arc cos hyperbolic means cos h inverse it is. So like that we can use. Then the other aspect is, the next thing that we take is like let us see, there are some of the constants in this python. So we can use those constants directly. For example, I'll say math dot pi, because every time we take generally pi value is 3.14, so which is not accurate. Okay, because that 3.14 is only up to 2 digits. Okay, now if I say math dot pi, now what it gives is, let us check it. So yeah, this is a pi value up to approximately 20 decimal points. Okay, 20 digits after the decimal. So this is most accurate value. So whenever you want to use pi value now, so please import it from the math library, so that the value of the pi will be accurate, then your solution will become much more accurate. Okay, so this is about the math.pi. Now next to the other constant is that we have e value. Okay, for example math.e exponent, this value all of us know 2.7. So generally, now let us check it, what is its value. So similarly, yeah, I think yeah, it is 2.71828182884, like this. So similarly, so if you want to use any type of mathematical constants, so please import it from the library, so that the accuracy will be more whenever you are writing a program or whenever using this value in any other particular cases. Okay, similarly the other thing is that we have math.tau. So this tau is used for precision. Okay, so this is also a constant which will be used in case of precision, and the value of which is equal to, generally we use 6.2, like that. So but this is a full value which is, you know, approximated up to 20 digits after the decimal point. So 28318, something like that. You can see the value on my screen. Yeah, and the next function that comes is not available and infinitive. Okay, for example what we can use is math dot math.inf, because most of the times we need to use sometimes infinitive. So this gives us like infinite. Okay, so you can directly use in wherever you want to write, because mathematically we can indicate with a symbol, but if you want to write in a program infinite value, so you can import from the math, and that will be useful in any program. And the other one is something not a number. Okay, so whenever data is there but that is not in number format, so usually that is indicated with NaN, capital N, small a, and capital N, NaN, not a number. So that also is possible. So for example, if I say math dot n, then it says it will take it like a string format or any other format that will be. So this indicates that that data is not more anymore, it not be like number format. Okay, so not a number, that is what the NAM. So like this we have constant e, constant tau, constant pi, then infinitive, then NaN. So these are the things that we can use in this import from this Python math library. And now next that what we discuss is it has also has like distance. Okay, so if you have 2 points like x1 x2 and y1 y2, so regular distance that is called as a Euclidean distance usually. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. So whatever the distance that we can calculate in between 2 points, so directly we can do here. So let me say for example x equal to, or let me say x5 equal to math math dot dist distance. Now in between which points? Okay, so let me say I want to take distance between 0 comma 0. Okay, and the second point is, let me say 2 comma 2. Okay, so here 0 comma 0 and 2 comma 2, that is what generally it will be same. So I want the distance of 2 comma 2 with respect to the origin. So this is what my intention. Now if I say I'll print so x5, so what it gives is, yeah, the distance is this one. So square 2 square 2 minus 0 whole square, that is 4 plus 4 square root of 8 it is. So that's what the distance is. For example, now if I make the modification maybe 1 comma let me say 2, then 2 comma 4. Now I need the distance between these 2 points, then ultimately it will be like 2.23, the distance between those two things is. So this is how we can directly get distance function we can use. So here we are calling the points in the form of a list, so it takes only 2 arguments. So in 2 arguments, this is the first point and this is the second point. So each and every point will have 2 coordinates like x coordinate and y coordinate. That's how generally it will be used. Function is we can directly calculate hypotenuse. So if you have a right angle triangle, then if you know the adjacent sides, then we can calculate hypotenuse using Pythagoras theorem. So if a and b are your sides, then if you want h is your hypotenuse, then h is nothing but root over a square plus b square. That is what generally we use. So for example, if I say x6 equal to math dot hypot is a function we have, hypotenuse of let me say 3 comma 4. This is what the length of my sides in a triangle. Now based on this length I want to calculate hypotenuse, so let me print here. So what is the value of x6? So this is x6. Now if I execute this program, then what I will get is, you see this is what 5, yes, 3 square plus 4 square, square root is 9 plus 16 is root 25, that is nothing but a 5. This is the right answer. Okay, so like this we can compute hypotenuse, we can compute the distance between 2 points. Okay, so all these things we can do. So these are all the functions that are available in the math library. So thank you guys.